everybody, it's Maris Wicks. Thank you for tuning in to the live draw along. Just want to introduce myself. I am a writer and illustrator of science comics. This is one of my books. It's about coral reefs. Before I did that as a full-time job, I spent 8 years as an educator at the New England Aquarium, talking to folks about cool stuff in the ocean. So today we're going to be focusing on one of my favorite groups of animals, cephalopods. I have my little squid friend with me today. But we're going to be talking about giant Pacific octopuses, dwarf cuttlefish, and also long-fin squid. So octopuses, cuttlefish, and squid. And before we start, I want to just do a quick overview of cephalopods. They're a group of animals that are soft and squishy, for the most part. We'll talk about a couple sharp parts they have. But they're invertebrates, so that means they don't have a backbone or a spinal cord. So when previous live draws, we've talked a lot about looking at body shape and fins or limbs or appendages, mouth, eyes, patterns of behavior. We're going to do that. But I think there's some really cool parts about cephalopods just because a lot of invertebrates tend to be very different from mammals like us or birds like what we did last 2 weeks ago, penguins. So you do not have to be an artist to join along today. All you need to do is have something to draw with and a piece of paper. There's no right or wrong way to draw these animals. I like to share how I draw because I draw a lot of animals in the work that I do. And if you know my drawings, they're pretty cartoony, but they're also informed by references on science. So I like to be inspired by things in the natural world, but also kind of add a cartoony twist to them. So yeah, no right or wrong way to do this. Feel free to draw along. Also feel free to if you want to just be inspired by these animals, you can write poems about them. You could do a sculpture if you wanted to join with Play-Doh, whatever floats your boat. So it's basically just a fun way for all of us to hang out together and appreciate cool ocean animals. So we're going to switch it up so you can see my screen. And I'm drawing today with a Wacom tablet. So it's a tablet that connects to my computer via USB, and it has a stylus. I actually prefer to draw with pencil, but this is the easiest way for me to draw and share what I'm drawing with you through technology. So draw with whatever feels comfortable for you. I'm a big fan of crayons, but I also really like pencil because I sometimes need to erase. And erasing does not mean you made a mistake. It just means you're still working on your drawing. Erasing is often just as important as making marks. So up first on the screen is a giant Pacific octopus. These are one of the biggest octopuses. I think they are the biggest octopus. They can get really, really big, like tentacle to tentacle. If they stretch them out, I think it's 30 feet. There is at least one giant Pacific octopus that lives at the aquarium up in the Northern Waters Gallery. And this was my first introduction to seeing an octopus. Probably, I've never seen them diving before. But I've definitely seen them at other aquariums. So they're an animal that's definitely hard to see in the wild, but pretty fun to see in places like aquariums. So for an octopus, when I was talking a little bit about how body shape is kind of a big indicator of how we start with our animals. So I'm going to just do a quick sketch of the back part. Is kind of like an oval or a football. And this part is the mantle head part. I get confused with octopuses. I'm where's the head and where's the mantle? I'll just assume that the head part is kind of where the eyes are. So, and if you've ever watched an octopus, you know that they can change their shape a lot. Remember those squishy bodies? They have the ability to fit into really, really, really small places. So I'm going to do kind of like a standard octopus pose, and then maybe we'll do some action shots because they don't just sit around on the rocks. So we've got two eyes up on the top, and those are kind of like two little mountains or two little D's. I'm sketching the eyes there. And then maybe I want to make this football a little bit like that. And then I'm going to draw, I've done this before in our drawings. I draw kind of like a little line across, and I'm giving this some three-dimensionality. This is just here for me to know where the center is. And I'm going to start to work on the arms. Now, octopuses have 8 arms. So I'm going to try and get them all in there, but I feel I always tell people, if you get overwhelmed and there's 6 on there, just put a couple peeking out from the back. But I do try and make sure that I draw an octopus with 8 arms. And we'll get to cuttlefish and squid in a little bit because they've got some super extra special appendages that I'm excited about. So for my arms, if you think of an octopus, I like to try and have the shapes of the arms mimic the movement of them. So they don't just have like, I mean, sometimes they reach out an arm like this and they're like, hey, maybe they're punching a crab or something. I don't know. Oh no. They don't actually punch crabs, but we will give this octopus something to eat later. I like to try and think about their movement in the water. So I know I'm making a static drawing, but think about, and maybe not, maybe you need something better than your imagination or different from your imagination. Think about videos you've seen of octopuses. So I like to think of them maybe flowing or grabbing onto stuff. And these are just my guides. And I'm kind of just going to do them as lines first. So we've got that. And I'll do another one like curling up here. And again, just starting with the line part. And I feel like this helps get where, so we've got 1, 2, 3, 4, 5. And then maybe we need another one in the back here rolling around. And maybe there's one that's going underneath that one. And I might actually today with this drawing, I might put my sketch here and then I might draw on top of my sketch. And again, no right or wrong way to do it, but sometimes when I'm drawing something that's a little bit more complex, I like to have my guide underneath. So I think we're almost, we've got 1, 2, 3, 4, 5, 6, 7. And I'm gonna do maybe one more in the back here, reaching out. So I'm gonna give myself another layer. I'm gonna make this one a little bit more faint. So pretend that I drew a little bit lighter here. And I'm going to go back in with my sketch. And you can draw right on top. I'm just, so football shape. That part's still important. And let's get some arms in here. So now I'm just going to use my guidelines kind of to just beef up those parts. So I'll use them as a guide to make them, I don't know, think of them more as like flexible hot dogs now, as opposed to just like skinny pieces of spaghetti. And we will get to the sucker discs. I like to think about, like, in terms of details, I like to get the main part of the animal there first. And okay, got our eyes here. Another curly Q one. Maybe this one's actually going up and around. And there's one of the things that I think is difficult that I always have a hard time is thinking of a drawing in 3-dimensionality. So I don't have a octopus toy or stuffed animal, but that is one of the easiest things to use as a model because you can kind of pose it how you want. I do that with my squid friend here. But I find that a lot of times when an animal is very complex and has a lot of parts, it's a lot easier to use a reference that's not just a photo, but like a 3-dimensional reference. And I've talked a lot about how I personally, like, I love to use toys or models to help me draw because maybe you want to draw the underside of an octopus or draw it from a different angle, and a 3-dimensional model can really help. And I know some people would be like, "Oh, you're using photos? Like, isn't that cheating?" I was like, "Nope." A lot of artists, especially when they are drawing real things or real places, rely on photos to help inform how they draw those things. When I'm not doing ocean theme stuff, I do books that kind of are, I draw books that are biographies of people, and I have to look at photos of the people in those books and draw the cartoony version. So it's totally okay to be inspired by photo references and, you know, to do your research before you start drawing or even while you're drawing. So let's see if I ended up with all of the right tentacles. Sorry, arms. This is the other thing is I sometimes get a little overwhelmed with what is what. And I believe for octopuses, these are arms. And we'll talk a little bit about tentacles in a little bit, but I also don't get caught up too much on the words. Like, I try and be accurate as possible, but I don't want to, like, I'm not gonna like call someone out and be like, that's not the right way to say it, because I pronounce lots of stuff wrong. It's hard when you read words but you don't hear them out loud. So it's okay. Like, try and be like, when you're learning new things, like, you don't have to get frustrated if someone doesn't know like the exact factual things. When I think about what I'm sharing with people, I try and think about the big picture, and the big picture for me today is just like talk about the basic anatomy for a lot of these animals and share a little bit of information about them. But yeah, and sometimes I get all nerdy and I can't help it. I'm like, actually, that part's called the, actually, you know what, speaking about parts, octopuses have a siphon, and you might see it. It kind of looks like a little like tube or funnel that sticks out. We're going to give this friend a funnel or tube, a siphon, right there. And it kind of, it's kind of shaped like an ice cream cone with the bottom cut off. And that's really helpful for, so inside this big part of the octopus, the head mantle-y part, is octopus's organs. And octopuses breathe underwater, so they need water to go over their gills. So that siphon helps to suck water into their mantle and just cycle it through. Now, you also might have noticed with octopuses that they might be interesting texture. So we'll talk a little bit about the skin. So, masters of camouflage, of course, but octopuses can change the color and the texture of their skin. So you might have an octopus that has these cool, like, little raised bumps on its skin. It almost looks like sandy or a little rocky. Also, I think this friend maybe needs some eyes. Let's give this friend some eyes. And this is where I get a little less scientific with my drawing. I use a little bit more cartoony eyes. Now, I think it's difficult to draw octopuses because does anybody know where their mouth is? So can't see it right now. It's like underneath all of those arms, and we'll do a little like octopus talking part when we get done with this drawing. But it's kind of difficult. So a lot of times you will see. I'm going to move my squid buddy because sorry friend, making it a little difficult for him to draw. A lot of times you'll see an octopus and people will put a mouth there, and I actually think that's pretty cute, but that's not where their mouth is. So that's all up to you. You can let nature inspire drawings and have them be super cartoony. They don't have to be factually correct. But for me personally, I kind of like to try and make them factually correct. But let's get to those sucker discs. So octopuses have sucker cups or suction discs or whatever you want to call them all over their arms, and they're used for helping them hold on to things. They're also sensory, so they can feel. And they can kind of taste as well. Sensory stuff in octopuses is just really cool. And I was talking in the beginning about how invertebrates are like pretty different from us. They have a lot of different things about how they experience the world just because evolutionarily they're just a lot different from us. But they just have really neat stuff that they can do. So having super sensory arms are helpful for navigating your environment or trying to find food. And they can hold on really tight. If you think about if you've ever been in the water, or maybe you've been fishing and you've caught a fish and like thought about how like they're covered in mucus, they're pretty slimy. It would be pretty difficult to catch your food. So it's to the octopus's advantage to be able to have good tools to catch their food. And in this case, the tools are part of their body. So I feel like drawing the tentacle parts, the suction discs, are like pretty meditative. I think it's really fun. And I think an octopus is a really like nice animal to draw to kind of just get lost in all the little parts and details. So yeah, I mean, I also really enjoy when they're in the coloring books because I'm like, yes, I get to color like all these different parts and it's super fun. But with the arms, you can think of kind of the three-dimensionality part. Like maybe you only see the suckers on the bottom half, and in this case, they look like little rectangles. But as the arm winds and wraps, and we can get a little closer up if that's easier, so you can see this a little bit more. Maybe you start to see a little bit more, and they actually, this arm is twisting around. So, and this is again, like, I'm getting a little fancy and thinking about the 3D parts. And I should say that I'm in my late 30s. I've had many, many decades of practice of drawing. And I've looked at a lot of octopuses. So this is kind of part of my job, is to research and draw cool ocean animals. So again, we're just kind of going in here and drawing the fun parts. And then we're going to do a little bit of looking at some other octopus anatomy. So I'm going to shrink this friend, I think. Oh, I'll keep going with the arms. I was like, oh man, if I pick octopuses, this might be a while. And I don't want anybody to feel rushed. For me, a lot of times I'm doing these just so I can fit in like a couple different animals for the hour. So like if you're like, oh, I'm not done with my octopus, it's totally okay. Go back to it afterwards. And I know there's pictures popping up that are pictures of animals at the aquarium, and I'm showing those as an example of how I use reference. But feel free to just like Google image search, or if you have books at home that have animals in them, or if you have like favorite shows. I actually sometimes just like try and find YouTubes of divers and see if they like post cool diving videos. Same thing on Instagram. I follow a lot of underwater photographers, and it's just really cool to be inspired by their art, because photography is an art, and they're capturing a whole different feel of the underwater habitat. I do want to give this friend a habitat. a lot of octopuses prefer rocky places or places that they can hide because being soft and squishy means that you're delicious to a lot of other animals in the ocean. And even me, I've been known to eat cephalopods. And we're actually, when we talk about squid, I'll talk a little bit about their role in terms of how they're a source of food for not just people, but also other animals. So kind of big food web stuff. So, and I feel like sometimes the habitat can give your animal a sense of place. So, and I'm just drawing like really general rocks back here. And maybe you want to just do a little shading underneath. Octopus. Okay. I am going to make this friend get a little more faint. And I'm going to kind of use my original drawing as inspiration and draw the same octopus, but let's see if we can do an underneath part. And this will be a bit of a challenge. So I mentioned that underneath that octopus, there is a mouth. And octopuses have a mouth like a beak. It actually looks like a bird beak. It's really, really cool. So maybe we'll have this octopus like just say something. So we'll go from this position to this position. And I'm kind of thinking about, again, this is me using my, like, I have lots of practice of like using my brain to think of a thing in three-dimensionality. So this isn't the first time I've drawn something like this, but I would say if it was, I would either A, try and find a picture, or B, use a toy or a model or something to help me with this drawing. So this is, I feel like this is a little, okay, we got 1, 2, 3, 4. And I'm trying to think of what we should have this octopus saying. I think that's 6. Maybe we'll bring the crab back. I think that's maybe a good idea. And maybe you're surprised that an animal as soft and squishy as an octopus enjoys crabs, but their beak is made out of kind of the same stuff as our fingernails. So it can be pretty, pretty hard. I'm going to get rid of our drawing in the back because that looks a little confusing. I'm going to do a little bit of erasing. And we're going to see if we can find this octopus a little bit of food to eat. Our eyes. And I'm going to go back and see if I can get the right. Okay. I don't know. I'm worried this is making me looking a little terrifying, but you know what? That's okay. So I got a beak in there. Oh, hi. And maybe this octopus is like, you know what? I heard that it's nice to compliment your food before you eat it. So let's draw a crab here today. Bonus invertebrates. And a lot of times I will start with the eyes. I know it's kind of a weird thing to do. But I don't know. Sometimes it's just like I said, there's kind of no wrong or right. Sometimes I just let the drawing, I zone out and I'm like, okay, how's this going to work? And again, I practice a lot. I draw for my job. So that means it's what I've been doing for a very long time. I also draw for fun a lot, and my job is fun. I'm careful to say, like, I love my job, but drawing for fun for me just means I draw and I'm drawing just for me. I'm not drawing, for something that is work. And both of those things are really fun, but drawing for me means I'm not as worried about making mistakes or following the rules. It's really free. And sometimes I even want to do stuff like finger paint and just like do abstract stuff because it's just fun. Like the act of making art to me is really fun. I also do stuff with like woodworking. I'm working on some cutout like lawn ornament penguins right now, which is like a whole separate thing. So, okay. I think we're going to get a little, you look delicious today, which I think would be I say that to my sandwich sometimes before I eat it. And as I'm doing this, because I'm wrapping up the octopus part, if there's anybody who has any questions about drawing today or about any of the animals that we're talking about, please feel free to leave a question in the comment and I can answer that question for you while we're drawing. So any questions from anybody today about what we're doing? I'm sorry, I forgot to tell you that was a thing you can do. Okay. Oh, have I ever gotten to travel anywhere that I get to observe octopus? So I've definitely been diving in places where there are octopus, but I have not seen any. In the Caribbean, the kind of like most popular cephalopods that I saw there was actually at night, and Caribbean reef squid, which are just like so beautiful and shimmery and rainbowy. Since I was a kid, like I always love animals that like have iridescence. So I love any animals that reflect rainbows because I just like I think it's I mean, I understand how light works, but I also think it's magical. Like I know it's refraction, but it's also like, ooh, pretty rainbow animals. So yeah, sadly, I haven't been able to hang out with octopuses diving, and I'm hoping that that will change. I'm hoping someday I'll get to go to where there's more octopuses. One of the things that's tricky is that like I live in New England, so a lot of times I'm beholden to getting more excited about the local critters. So like I've definitely seen squids on dives and things like that here. But yeah, so there's a lot of stuff that when I dive, when I do see it, like I just squeal underwater. So it's basically just like, so like sharks are one of those things. I get really excited to see sharks because I love them so much. And it's so, I don't know, like I love being able to see animals in aquariums because I think it's a really important way to connect with them, but it's also really special and a privilege to see them in the wild. But yeah, I don't know if I have like a wish list octopus. I mean, it would be amazing to see a mimic octopus. I'm not going to talk about them today, but if you don't know what a mimic octopus is, please look them up. They're incredible. They also probably get the award for like most stylish octopus, if that's like a thing that I can give out. But yeah, I know no octopuses while diving. I'm trying to think if there's been any fun sex. The main thing, like if you're psyched about invertebrates in general, one of my favorite, this is like my introductory animal in New England, is I love periwinkles. And periwinkles are a small marine snail that you'll find all over the rocks if you go to the beach. And they're just adorable. They're really fun to watch. They eat algae. If you go tide pooling, they're great. And then like if you want to like look for my favorite snail, and again I'm talking about snails because they are mollusks, so they're in the same family of octopuses. The moon snail is incredible. If you've ever been to the beach and you've been walking along and you've seen clamshells that have like a perfect little circle, looks like someone drilled into them, that's the moon snail. So thinking about these animals that have these squishy bodies like the octopus with its beak, snails, and specifically the moon snail, has a really sharp radula, and that's their like mouth parts. So they basically have like they're super squishy except for their shell, and then there's one part that's underneath their mouth that they can scrape away at a shell and then suck out the insides like you're sucking it up through a straw. And I just think it's great. Any other questions? Okay, that is totally fine. Yeah, okay. So we're gonna, and I, yeah, we could put some. I would be pretty scared if I were this crab. Oh, I have one more kind of interesting aquarium specific anecdote about this. So, octopuses are super smart. And that's not just me saying that. There's been lots and lots of different studies about like how they can solve problems and puzzles. And part of that is like, okay, they're good at hunting and catching their prey, but part of that is just like engaging with their environment. And at the aquarium, a lot of times if they want to have something like enriching for the octopus, instead of just like dropping a crab in there, they have a clear box and that has a latch on it. And they have a bunch of different clear boxes. And you can put the crab inside one of the boxes, and the octopus will actually have to manipulate the lock mechanism to get the crab out. And it's, you know what it's like to be kind of like stuck at home and you're bored and you need something to do. That's not unique to humans. It's really important that a lot of animals stay engaged and interested and have like challenging things to do. And that's part of the responsibility of not just feeding the animals at the aquarium, but like making sure that they're getting intellectual stimuli, so getting their brains working. And I think it's kind of a cool way for us to also observe and understand how they solve problems, because like I said, these animals are very different looking than us, but they're very capable of figuring things out. And I don't know, I think like animal intelligence studies is really fascinating. And one of the things that I try and remember as a person is that it's unfair to base animals and how smart they are on human intelligence, because like, yeah, of course we're like, oh, humans are smart, this animal can't do this thing that we can't do. And it's like, well, that's not fair, because like, can we use echolocation to catch our food like a dolphin? Like, can you taste with your arms like an octopus? No. So I think the study of being like, how do animals experience their environment and how do they survive and what are cool things they do is like a really cool part of marine biology. And again, I don't have a scientific background, or at least I don't have an academic scientific background. I've spent a lot of times doing science communication, but I think that that's like one of the cooler parts of if you're interested in a career in science, being able to observe and study animals is like, I don't know, it seems like it would be a really fun job. And I do get to accompany scientists in their field work and help communicate their science. So that's how I kind of scratch that itch. So, okay, let's move on to our cuttlefish. See you later, octopus. Good luck, crab. Sorry. I didn't know they'd be eating today. Okay. So, oh, and I meant to say, I'm on the top left. I like to post the common name of the animal and also their Latin name, their sciencey name, just in case you want to look them up and look at pictures on your own. It's also to just kind of draw general, like a lot of times, sometimes the cuttlefish that I draw might be a dwarf cuttlefish, but it also might be a little bit like a common cuttlefish, or we might talk a little bit about flamboyant cuttlefish too, which are another one of my favorite species. So I mentioned that octopuses like rocky habitats, and sometimes you'll find them in sandy areas as well. Cuttlefish are another type of cephalopod. They like sandy parts, and we're going to talk a little about their body shape and as I draw them, and then we'll talk about how they catch their food, because I feel like they have, I mean, they all have superpowers, but cuttlefishes can do some pretty cool stuff with some of the appendages they have. So kind of similar to our octopus friend, we've got that little football or like egg shape. And again, that's the mantle. Now in cuttlefishes, they have fins on their mantle that help a little bit with locomotion. So I'm going to add basically just like a little wavy ocean line there. They've got a siphon. So at the bottom, we'll put our little siphon in. We'll do a little erasing. I like to give them pretty big eyes just for fun. Face and eyes on animals are a lot of times how we read things, and not just other people. But you know, think about it. If you've been to a farm, like you're more likely to like look at the face of a horse or look at you know, the face of a cow than to be like, I'm looking at its feet. And maybe you're excited about looking at its feet too, and that's totally fine. But I do think that like we gravitate towards looking at other animals' faces. So when I'm communicating with doing science communication with cartoons, I think a lot about the face and the expression. And this is where I break not necessarily rules, but a lot of times I am kind of giving these animals, you know, I'm having them say things or having them like have more human emotions. And a lot of that is just helping me to tell the story. So I'm using a little bit of fiction and nonfiction with the cartooning that I do. And I'm okay with that. And I think for the most part, the reader is understanding of that as well. So for our cuttlefish, we've got some little arms. I'm going to do 4 little arms in the front, and then there's 4 little arms in the back. And I'm just going to give a hint of the arms in the back. So we'll kind of color them shaded in the back. You can draw a few more if you want. But cuttlefish, and you might not see them if they're just hovering, have 2 other appendages called tentacles. And they use those tentacles to catch food. So I have drawn a shrimp. Uh-oh, you know what's going to happen. This is just all about eating today. And that cuttlefish will see that shrimp, and then it can lightning fast shoot out its tentacles to grab that shrimp. And this is kind of the same way that I approach like ice cream sundaes. I'm not as fast, but like, you know, when you're just like psyched about something, you're like, I can't wait to eat that thing. I feel like I'm a cuttlefish when it comes to stuff like that. I can't help it. Now, they are very flexible because like I said, sometimes you won't even see their tentacles when a cuttlefish is just chilling, but they can stretch these out, and they've got kind of little paddles at the end, and that will help them catch their food. So, and we'll do a little, oh my goodness, that shrimp is surprised it's going to be lunch today. Now cuttlefishes can also change the color and texture of their skin. And a lot of times you'll see cuttlefishes that kind of have like maybe a standard, like almost looks like ocean ripples on the top of them, and then they'll be light on the bottom. And we didn't really talk about this with the octopus, but we'll do this. And so a little darker on top, and a little lighter on the bottom. And we've talked about this before with our penguin friends a few weeks ago. A lot of animals in the ocean have a dark on top and a light on the bottom. Kind of think of shading. It's called Kappa shading. It's a type of camouflage, and that just means if you were a predator or an animal that was looking for a snack and looking down on top of this cuttlefish, a lot of times they look like the sand that they're hanging around in. And if you were an animal on the bottom looking for that cuttlefish, if your belly is white, you're going to blend in with like the sunny part of the surface of the ocean. So it's just like this double camouflage that helps. And like I said, cephalopods have tricks up their sleeves where they can change the color and sometimes texture of their skin. So maybe this cuttlefish has swum over to a place that is darker sand, so maybe it wants its skin to be a darker color, and they can do that. They've got these. Actually, you know what? We'll do a little thing that I like to do in comics where we're going to pretend that I have a microscope, and I'm going to draw a circle, and it's going to have too thick of a border. So hold on 1 second while I fix that. Let's go 7 pixels. There we go. And this is one of my favorite parts of comics and cartoons, is that I can pack a lot of information into a drawing. So let's take a microscopic look. So this is kind of a graphic way to do this. And when I say graphic, I mean like a designy way. I'm not actually gonna like cut up this cuttlefish. But I'm gonna let you know that this circle is zooming in on that little section of the cuttlefish's body. So we'll take a look at their chromatophores. And chromatophores are light cells that can expand and contract. So if this squid wants to appear lighter, it's got these little tiny specks on its body, and some of them are thicker and some of them are thinner. And I was talking about cool, pretty rainbowy animals. A lot of cephalopods also have kind of like a sheen, like an iridescent sheen, so they might look rainbowy, and I know that that is the case with sometimes the squid friends. So here are our chromatophores, and if this cuttlefish wanted to make itself darker, it can actually expand these colored cells to make them bigger, and they would fill in and get closer to each other, and it would look darker to your eye just by using these cells, expanding them and contracting them. And it's kind of wild because I know there's people who are studying how they do this. And it's not as simple as them using their eyes to look at their surroundings and have the chromatophores change. So I could be wrong about this. I might need to do some homework about it, but I think that it's kind of more like their skin can emulate what's nearby. So it's almost like they're thinking with their skin. And again, I might want to double check. A lot of times science is a pretty big field and a changing field. So sometimes the information that I learned when I was a kid, or even just the information I learned 5 years ago, might be a little different now. So it's a challenge, but it's also exciting to keep up with like what's going on currently in science. And I realized that this looks like a soccer ball, which is actually not that unlike what their chromatophores look like. And I know there's some students in Rhode Island that did some really cool chromatophore experimentation where they were looking at how the cells, the color cells, open and close. So there's some really cool footage online of like you can actually watch video, microscopic video of cuttlefish skin or squid skin changing color. So yeah, little microscopic view. I think I would like to, let's see, what did I want else would I want to talk about with cuttlefish? Oh, I wanted to talk about another sciencey piece. And, we've talked about how they can change the color and the texture of their skin, but there was some scientific research done with putting cuttlefish in front of checkerboards. And I've done a lot of diving, and as far as I know, checkerboards are not something that show up in the ocean. But scientists were wondering if maybe cuttlefish could change change their pattern on their skin to something that was a human-made pattern. And surprise, they did it. It's really, really cool. And I believe that was done in Roger Hanlon's lab. And I can send links to that later. But yeah, so super, super cool stuff. And I talk about our habitat again. Cuttlefish are usually found hovering kind of just above the surface. And I don't have a picture for this one, but I want to end cuttlefish on talking a little bit more about their color changing and maybe their movement. I wanted to talk about the flamboyant cuttlefish, because that is a cuttlefish that uses its color changing and movement to actually attract prey, which is kind of a cool thing. So let's turn off those and do one more layer. And if anybody has any questions, please feel free to ask. It can be about drawing, it can be about cuttlefish, and I'm happy to answer during the chat. Let's see. Football shape. Got some eyes. And depending on what cuttlefish.
Still no questions yet, but
totally fine.
I know I have a bunch of great stories of the cuttlefish doing cool things at the aquarium. I was wondering if you had any from your time there.
So, and this is based on only observation and no scientific reasoning. Multiple occasions, I had been talking to visitors that had brightly colored dyed hair, and the cuttlefish just seemed fixated on them. And I know there's studies about what cuttlefish can see, so I don't know. Maybe there's certain things that they react to, but I saw it happen so many times that I was like, I don't know what it is. I don't know if it's the reflection of the light. I feel like that's kind of the most interesting. I watched them for long enough. I will say that so the aquarium has a cuttlefish breeding program, so they'll actually rear cuttlefish. So sometimes it's really cool to see their eggs on exhibit, or when they introduce little baby cuttlefish. I think it's really cool life cycle wise to be able to care for an animal and have it reproduce and have generations of these animals in aquariums. Did you have a good cuttlefish story as well, Brittany? Or you don't have to share it if you don't want, but.
I just always think they're really cool to watch. I could just watch them for hours, and they always seem to be checking you out as much as you're checking them out. I always find that fun.
Yeah, it's something interesting, right, to be observing an animal and have them observe you back. And I think that's definitely a unique, I feel like that's not something that happens very often with invertebrates. Although, again, I can't speak. I think it's just easier sometimes to maybe read a animal's engagement based on it fixating or watching you or following you. So I think that reflective curiosity is a really cool thing to experience. And people who have pets who are watching today, no matter what kind of pet that you have, you've got a bond with the animal that you have, whether it's just hanging out with a cat or even, when we had cats growing up, our cats totally knew when I was sad or stressed out. They would just come over and be comforting. Same thing. I think of the dogs we had too are pretty attentive to that. So it's really interesting to think about human animal relationship. That's why I try and be really respectful of thinking about them as I don't really know what it's like to be a cuttlefish, and I think it's important to, again, like I said about animal intelligence, approach it being hey, they can do a lot of stuff that I can't do. I wonder what the world is like for them. So with the flamboyant cuttlefish, it can make these kind of patterns that kind of make it looks hypnotizing. It looks kind of like a spinning spiral. And the flamboyant cuttlefish will do that and have these really cool patterns and colors. And scientists think that this is a method for them to kind of hypnotize their prey. Not maybe hypnotize, but distract their prey so that the prey's what is that? I don't know what it is. So maybe we have to have a really surprised shrimp over here in a second, and I'll do the little bottom, get this guy a second. And let's see. So I don't know. Let's see what we could do for hypnotized shrimp eyes. And again, I know I'm using my artistic license a whole bunch here. And that shrimp is oh my goodness, I've never seen this before. It's amazing. And you can probably imagine how that's going to end for the shrimp and the cuttlefish. Delicious lunch. But yeah, it's so cool to just see this stuff. Whether you're learning about it in a book or watching a documentary of it or observing it at the aquarium. And I know the aquarium did some really cool slow motion footage with feeding their cuttlefish, and I think it's on their YouTube, but it's worth looking up the video because it kind of is a perfect actual example of what I showed you with this drawing before, where you've got their tentacles just zoom, reaching out and grabbing their prey. So definitely check that out. I feel like it's pretty inspirational to watch. And you can also compare and contrast. You can be oh, some of what Maris drew kind of look like the cuttlefish, but there's different characteristics that look a little bit different when you see them in real life. Because again, like I'm doing kind of like the translated version of what I feel like the animal is to me. So there's part of us that's kind of personal, and I like that. Like it's my cartoony way of seeing the world. So we're gonna move from and I actually before we move to cuttlefish, I'm gonna do a little like cuttlefish anatomy on the inside, and I'll make this one go a little bit. Sorry. No, come on. So much clicking. Octopus, as I said, were pretty squishy except for the beak part, right? Cuttlefish have a cuttle bone inside, and it's not like a bone like you or I have, but it's kind of calcified, almost like a shell. So on the inside of their body, it's a support, and it helps just give them shape. But it also means they can't really squeeze through as many tiny things as a octopus might. So, and it kind of just looks like a little. It's similar shape to their mantle. But what's interesting about cuttle bones is a lot of times people see them with birds if you have bird pets, because cuttle bones are they're basically really high in calcium because they're kind of like a shell inside the cuttlefish's body, and a lot of times people buy them for their pet birds as a source of calcium for them, and it's just the cuttle bone. They don't just like throw a cuttlefish in a bird cage. But I thought that was kind of like I didn't know about either of them when I started working at the aquarium. I was like, oh, I have no idea. But it's interesting to see how invertebrates often give their body structure. So some of them are just full on squishy, but then you can think of other mollusks. So, snails, and they have that calcified shell that they build. It's part of with them. It's kind of like having bones on the outside. But it's interesting to think about adaptations that help these animals survive. And as far as I know for the cuttlebone, it's pretty much just giving structure to the cuttlefish's body. It's a little confusing that we call them cuttlefish and they're not a fish. That happens in the animal world. I always kind of say like, well, seahorses, they're not horses. So again, this is kind of why I like to have the common name and then the sciencey name, because sometimes it does get a little confusing where you're like, wait, what is a fish? Fish are vertebrates. Cuttlefish, not fish, invertebrates. So we're going to move on to an animal that you will find at the aquarium. Oh, sorry, I have to get rid of that drawing. Oop. But not alive. So long fin squid. And some of the pictures that are going to pop up for the long fin squid are of food prep pictures. And that's basically preparing food for the animals to eat in the aquarium. And then there's one picture of them schooling. And I wanted to choose long fin squid because they're a local species that you can find off the coast of New England. And if you eat squid, like if you have calamari, they're one of the species that humans eat. So we're going to talk about their body, and then I'm going to talk a little bit about their role in both their natural food web, their food web in the ocean, and then how they relate to us, because we're part of a food web too. We are animals. We eat other animals, or we sometimes eat other animals, so you might be vegetarian. So with squid, they have a very torpedo-shaped body. So, and when I say torpedo-shaped, we talked about this with fish too, back a couple weeks ago when we drew the barracuda. And a lot of times if you see an animal that has a shape like this on their body, that means they can be fast. And I'm not saying that the octopus and the cuttlefish aren't fast, but squids are kind of known for their fastness. So remember how the cuttlefish had the little like ripply fin? Squids have these fins at the top, and they're pretty much shaped like a triangle. So imagine that I drew a triangle, and I'm doing a little bit of drawing in 3D here, but you can kind of see the triangle shape. So we've got their mantle, fins at the top, a little flappy. And then let's get some eyes down here. Whoop. Whoop. And they have a siphon too. And then their eyes are here. And this friend is swimming right now. So we've got a very streamlined squid body, and they've got the four arms in the front, 4 arms in the back. There's 8 arms total, but then they also have their tentacles, and their tentacles are a little bit more visible than the cuttlefish is. You'll generally see them out a little bit more. It's easier to tell that they've got these 2 other longer appendages. And if you look up close, they do have suction discs, and with a squid, with these friends, they also have teeth inside their suction discs. So in order to draw that, I want to draw a close-up for you. I got very familiar with these animals because when I worked at the aquarium, one of the programs we did was squid dissection. And it was a program we usually taught for, you know, middle school, sometimes high school, sometimes older elementary school too as well. But it's a really cool way to see these animals inside and out. And they're food grade animals. So they're not food grade, but they're animals that we associate with food. And I think it's nice to show a connection between something local that we eat that is part of our food web, part of what's on menus. Because I do think it's important to understand kind of like those complex systems and to think of us as part of that web. And you know, these squid, and this is going to be confusing, I'm going to say fishery. Fisheries are basically just a name for like how we manage species that we eat in the ocean. And there are lots of regulations to protect these squid, and they're considered a relatively sustainable fishery, which means that they're managed well and that we're trying to not take too many. And they're relatively protected so that they can play the role in their ocean food web, but also play a role in our food web as something that we eat. So up close, the tooth ring might look like this, and there's a hard little part that looks kind of like a big fang, and there's a couple little tiny ones there, and each one of their suckers on their tentacles look like that, so that when they grab onto their food, and usually they're just eating small stuff like fish, that can grab on, pull the food into where their beak is, because they have a beak too, and the cuttlefish does as well, and then eat that food. But I want to take a look at the inside of this friend. So in order to make that a little easier, I'm going to rotate this. Let's see if I can do this. You're going to let me rotate. Nope, hold on. There we go. Boop. And I'm going to shrink it just a little bit. My computer is a little slow, but that's okay. Just happens when we're doing the chats. So we're going to do a little inside the squid because I wanted to show you some cool squid anatomy stuff. And I think I'll do the same thing that I did before where I'll do a little circle. So this is there. And then I'll do a new layer on top. And you know what? Maybe for the insides, I'll pick a different color. Oh wait, am I doing color on here? No, this is a gray one. It's okay. I'll go a little darker for that for the insides. So like I said, for all these animals, inside their bodies, like the mantle part, is their organs. And one of my favorite parts of kind of squid facts, sorry, hold on, where did I have to turn off the cuttlefish? Boop, longfin squid, is that cephalopods have 3 hearts. So inside their body, they've got gills, kind of go up the sides, and they've got little helper hearts at the top. And then there's kind of a main heart that helps get blood to their body. And that might sound weird to us because we have 1 heart, but I'm sure squids are just going to be like, oh my gosh, humans, you only have 1 heart. Are you okay? And we're like, yeah, it's okay. It's just like animals are, different. We've got different evolutionary stuff. We know we have the beak down here. So I'll draw my little beak friend. Again, it looks kind of just like a bird beak. And this is inside. So I wanted to do this for the inside part. So a little squishy part around the beak. And then their esophagus goes all the way up through their stomach, a little stomach in there. Now, my favorite squid part is their brain, because their brain looks like a donut and it actually goes around their esophagus. So can you imagine if your like esophagus went through your brain, like it passed through? I just think it's a cool, like, again, I know it's like not weird for squid because that's what their bodies are like, but I just love learning about the anatomy of other animals and being like, oh, that's so different from us. It's really, really cool. So I always like looking at the insides just because I appreciate these animals a lot more. But it's also, you don't have to do a dissection. There's also ways to learn this stuff by looking at illustrations as well. Because I try and also think about people's comfort with things like that. I've always been comfortable with dissection, but it's okay if you're not. There's lots of other ways to learn about the insides of animals that don't involve looking at them on the inside. But so insides of the squid, and I mentioned that these friends are schoolers. So one of the pictures has a whole kind of bunch of them. So I wanted to try and draw a bunch of squids in a group. So I thought that would be a nice way to kind of show them in their habitat. And I wanted to talk about, well, hey, why don't we have long fin squid at the aquarium? why are they only at the aquarium to feed the animals? And the answer to that is that, like I said, their fisheries are well regulated, and they're a pretty sustainable, a pretty smart thing to not just for people to eat, but to also feed the animals. And a lot of the animals that live in the aquarium, the bigger predators like sharks, some of the turtles, like squid, is something they would eat in the wild anyways. But the reason why we don't have them on exhibit is because they're an animal that doesn't do well in aquariums. And that's something that you have to consider. You know, what animals actually do really need to be out in the ocean? If you think about these squid, they're never going to really hit a wall of something. The only time they're going to really interact with the bottom of the ocean or any physical, like hard things in the ocean, is when they go to lay their eggs, because they need to root their eggs to the bottom. So maybe we'll draw a school. And I'm going to do this one from the side, because if you kind of look at them from far away, if you've maybe seen the drawing of them together, hello, we'll kind of think of their body shape as this far away thing instead of all the close up stuff. So kind of thinking about how they move. And maybe there's, I'll do this, I know I did this before with the octopus's tentacles, but this is instead for a large group. I want to draw some motion lines just as a guide to myself to guide where the squid are going. And this is something that I like to think about in the ocean when I draw ocean things. Movement. Everything moves underwater very differently than it does on land. So I think if there's ways that you can capture the movement of the water, and we talked about this with the octopus tentacles, that can kind of help you kind of feel like you're underwater. So does anybody have any questions about squids, drawing? I mean, anything. And it's okay if you don't. I like to ask, make time for questions the whole time. Any questions? Okay, sweet. Well, we've got, let's see. Oh, we've got about 10 minutes left. If you're like I said, if you're interested in mollusks, your best bet is probably to check out some snails at the beach this summer. And speaking of just summer in general, I hope everybody's drinking lots of water and staying hydrated. If you're tuning into this in anywhere in the Northeast, it's really, really hot today. It's going to be hot for a while. So please definitely take care of yourselves outside in the heat. It's hard. Maybe you'll get to go swimming in the ocean. That would be pretty fun. I'm itching to do a little tide pooling and hanging out with some of my ocean friends. But yeah, I'm trying to think of some other longfin. And I think what I might do is, so these friends are kind of hanging out in, and I'm doing some of them. So they do flap a little bit with their fins. So I've tried to change the shape a little bit of, like, you know, flappy down. But again, just kind of really distilling them into these shapes. And maybe we'll do some in the background. So just the silhouette. And this is more of like thinking about drawing an ocean scene. And that's something that, like I said, sometimes it's fun to draw an animal just by itself, but sometimes it's fun to like really kind of create the world that they're in. So maybe in the foreground, we do see a little bit of bottom with a little bit of seaweed, and we'll draw some squid eggs. And I think the last thing that I want to draw today is some squid babies, just because I think that would be really fun. I have a friend, Dr. Casey Zakroff, and he did his PhD on squid paralarvae, so teeny tiny baby squids, and how they might be affected by ocean acidification. And ocean acidification is basically the changing of the pH of the ocean, basically the changing of like how the chemistry of the ocean and how it's affected by climate change, so increasing temperatures. And animals that have a shell or have any type of calcium carbonate, like shell-like parts to them, how are they affected? So there's a lot of scientists doing research like that, whether it's on different types of snails. Corals is obviously a huge one, because corals are an animal that are squishy, but they make a hard calcium shell on the bottom. And I didn't talk about the squid's internal parts, but they have a pen inside their body, and it's kind of aptly named, because if you take it out, it basically looks like an old school stylus. Like, it looks like kind of a feather quill. It looks like that with a little bit of line running down it. And that is inside their body. It's like right in there. And it kind of gives them shape and structure the same way that the cuttlebone gives shape and structure to the cuttlefish. And the other part of their body inside that has calcium carbonate is kind of like inside there, like, which helps with like buoyancy and where they are in the water. And those are called, I think, statoliths, I think. There are some animals to like orient themselves in the water, and kind of like their ear parts are like their ears that help them stay in the water and like know what's up and what's down. Because it's, if you've been swimming before and been underwater for a while, it's like sometimes it's hard to like figure out where you are. So I'm going to draw a couple of the babies, and then we'll wrap it up. And if anybody has any questions, feel free to ask.
Yeah, I was just gonna say, Elaine just asked, what do baby cephalopods look like? So maybe you could expand on more than just squid?
Yeah, sure. So it kind of depends on, so what do baby cephalopods look like? It depends on the species. But for the most part, I'm going to draw a close-up of a long fin, like freshly hatched paralarvae, so like a little tiny baby squid. And that will give you an idea of kind of what they look like. So from right here, I've drawn some squid eggs that kind of looks like seaweed here. We're going to draw a baby from there, and this is going to be a little tiny friend. But the shape that you see, and they even have like chromatophores, is you still see that mantle, but it's really, and now you've got really big eyes, little tiny fins. Let me make their eyes the same size. And then you've got your little tiny arms. So, I mean, I think they're super adorable. The Marine Biological Lab in Woods Hole does have like a whole bunch of actual photos of these guys if you want to see the longfin squids up close. Baby octopuses look similar, but if you think about their bodies, a lot of times here, so I'll draw some of the chromatophores on there because it's really cool that like when they're born, you can see their color changing cells like already, and there's not a lot of them, but they're there. And this little longfin friend is going to look a little bit similar to cuttlefish as well. For baby octopuses, I think their shape looks a lot more like their adult form. So you can kind of like a tiny cute version of, I think this is a bit more what it does look like. It totally looks like the emoji. 1, 2, 3, 4, 5, 6, and I think so. If you want to go down like a rabbit hole of really fun larval critters, I definitely recommend looking up like larval forms or baby forms of cephalopods. But there are a lot of animals in the ocean that have very different larval forms. So look up like if you search for crab larva or a zoa, or even just like search for zooplankton. Mola molas, and I'm sorry, I can't help it. I'm gonna talk about a mola mola. Let's get the eyes on this friend. But yeah, very, very big eyes. Pretty much all the body parts are there, and then just like pretty small representation. And as they grow, they start to look a little bit more like their adult form. And I know that a lot of these animals grow very fast. Most of the animals we've talked about today, their lifespan is anywhere between 2 and 5 years. I actually should double check for the longfins. The longfin squids might have a longer lifespan, but for a giant Pacific octopus, I think it's 3 to 5 years. So some of these animals grow incredibly fast. And to start off as a giant Pacific octopus that's maybe a couple centimeters, like itty bitty, and then you're all of a sudden just like huge a couple years later is remarkable. And the larvae, the paralarvae, do play a role in the food web as well. A lot of tiny versions of animals when they're born, whether it's teeny tiny baby fish or invertebrates, are a huge part of the food web for animals that eat stuff like plankton. So it's not unusual for a lot of small stuff like this to get scooped up by bigger predators, or even just things that eat plankton. And we don't really think about plankton things as being predators, but they are eating little animals. I don't actually know if octopuses they must have chromatophores, but I think they might be smaller. The squids. But yeah, this is like the Muppet Babies version of like all the things we just grew, and it's really cute. But yeah, Google can often be your friend in finding these. And then the best part is that a lot of the photographs are going to be taken by scientific institutions or scientists. So it's also a really good way to learn about active marine bio that's happening. So definitely check out the Marine Biological Lab that's down in Woods Hole. I think you can find some of my friend Casey's work as well, and I can link to his name too. Any other questions? Okay, I'm going to put this just down at the bottom real quick. So if you want to look more at Casey's work, You can check that out there. And he's the one that studied these friends right here. But yeah, and then you can feel free to follow me on Twitter and Instagram. On Twitter, I do try and share lots of different people's science constantly. I like to retweet a lot of scientists. So if you're looking for scientist folks to follow, head there. And thank you so much for tuning in today. It was really great to see all of you. And I mean, I don't actually see you, but it was thanks for coming out. And me and my squid friend say goodbye. Say goodbye, squid friend. Bye-bye.